Welcome back. This is Middle School Math with Dr. K. Today we're talking about writing linear equations. Now, if you haven't seen my prior videos, I've done one on slope and one on the slope-intercept form. Those are a great watch prior to this video. They'll really lead into the material we're going to cover in this video, so I would suggest scoping those out first. If you're already comfortable with those topics, let's jump right in. Now the form we're focusing on in this video is y equals mx plus b. That's the slope-intercept form for the equation of a line. As a reminder, m represents the slope and b represents the y-intercept. This first example just asks us to find the slope and find the y-intercept. What's interesting about this example is it's an equation of a line that's in a different form entirely than what we've been using leading up to this point. Now that doesn't mean we can't make it into slope-intercept form, and often that's what you need to do. Take an equation and manipulate it to get it into a form that you recognize. In order to get this into slope-intercept form, we need to get y by itself. That means I need to move the 8x to the other side, and I'll do that by subtracting. That leaves me with 2y minus 12 on the left side, because 8x minus 8x is 0x's. On the right-hand side, I get 0 minus 8x, which is just negative 8x. Now, again, I'm still trying to get the y by itself, so I'll move that 12. You'll notice that the 12 and the 8x are not like terms. So when I get to the right-hand side of my equal sign, I'm just going to leave my negative 8x, and I'm going to put plus 12 afterwards. What that allows me to do is start seeing that format for slope-intercept form. That's what we're looking for. But we're not done yet because we've got 2y and we need 1y. In order to do that, we need to divide by 2. And anytime you multiply or divide in an equation, you have to do it to every term. So we're going to divide the negative 8x and divide the 12. That leaves us with negative 4x and a positive 6. From here, I can find my slope, which I see is negative 4, and I can find my y-intercept, which I can see is positive 6 or 0, 6. Once you know a little bit about slope-intercept form, a whole world of algebra opens up to you. For example, there's some interesting properties of parallel lines. So here I've got two parallel lines, the red one and the black one, and I want to write the equation for both lines just to kind of show you an important property of course, parallel lines. So I'll start with the red one. I know I want to write an equation in the format y equals mx plus b. In order to find the slope, I need to look for the rise and the run. So I've got points on a graph. It's really easiest just to draw my road map. And I see that I'm going up 1 and over 4. So my slope is 1 over 4. And I also see that my line crosses the y-axis at 5. So if I rewrite that, I've got y equals 1 over 4x plus 5. For the black line, I'm going to do something really similar. So again, I'm looking for rise over run. And what I notice there is that my rise and my run are the same. So when I write my equation, y equals mx plus b, my m, my slope, is 1 over 4 again. Now this time you'll notice the b, the y-intercept, is not the same. In this case it's 0, so I write plus 0, or I could leave it at y equals 1/4 x. What's interesting about this information is now we know that parallel lines have the same slope. There's a lot we can do with that. Let's check out this next example. Here we have a problem that says there's an equation of a line, y equals 2/3 x plus 4. It says write the equation of a line that's parallel to this line. So parallel, that's important, and has a y-intercept of 12. So again, we're going to approach the line using slope-intercept form. So y equals mx plus b. And what did we just learn about slopes of parallel lines? We just learned that they're the same. Parallel lines have the same slope. That's true every single time you've got parallel lines. So if I can see the slope in this equation, I can add it into my parallel line equation. Once I have that information, the only other piece I'm looking for is that y-intercept. And I've already been told it's 12. So when I write my final equation, I can just write y equals 2/3 x plus 12. Here's a problem that's really similar, but just a little different. This time we're still writing the equation of a parallel line, but you'll see that we're not given something perfect. We're not given something in slope-intercept form. That means we need to manipulate this equation first before we can even get to the actual question that's asked. So let's start with 2x plus 4y minus 12 equal to 0, and we need to get y by itself. That means I'm going to need to subtract my 2x, I'll need to add my 12, and again, you have to consider the fact that negative 2x and 12 are not like terms. The 2 has an x, but the 12 does not. That makes them not like terms, and they cannot be combined. From here, to get y all the way by itself, I need to divide by 4. Now remember, when you're multiplying or dividing in an equation, you have to multiply or divide every single term. So that means I end up with 1y, and I'll simplify negative 2 over 4 to get negative 1/2. That's my slope. I'll also simplify 12 over 4 to get 3. Now what I really need from this is the slope, because I'm writing the equation of a parallel line. For my parallel line, I know I have to use the exact same slope, which means I'll plug in 1/2, negative 1/2 for my m. And then the problem tells me that this line has a y-intercept of 12, so that's what I'll use for b. Although we did a lot of work to get to this answer, this right here is the answer. Everything leading up to it helped us to find the slope and then plug that slope into a new equation. Let's try another. This one says find the equation of a line with a slope of negative 2 that passes through the point negative 4, negative 6. Now up until this point, we've not done a problem like this. We know the slope, we can see that here, but we don't know the y-intercept. So let's start with our formatting. Let's start with the slope-intercept form. I already know the slope, so I've got my m, but what I don't have is b. So what can we use to figure that out? That's the question. Now, anytime you're given a point, what that gives you is an x and a y. And what do you notice about my equation? I have an x and a y. So what I actually want to do is plug in everything that I have, m, x, and y, and solve for b. So my y is negative 6, my m, slope, is negative 2. I'm going to use parentheses for my x. That's because m and x need to be multiplied. Otherwise, it's going to look like negative 2 minus 4. B is going to stay a variable. That's the thing I don't know yet. I'll even underline that just to kind of help us see that's what we're trying to identify. Now we want to solve. Negative 6 is equal to negative 2 times negative 4, which is positive 8, plus b. In order to find b, I need it isolated, which means I need to get rid of 8 by subtracting it from both sides. That tells me that b, or my y-intercept, is going to be equal to negative 14. For the equation of a line, I still have to go back and actually write it. Don't forget that step. It's really easy to lose that along the way. We've done so much work already. So I'm going to write my equation y equal to m, which we know is negative 2, x, plus my y-intercept, which is negative 14. So in this case, I'll actually write minus 14. This is the equation for a line that passes through negative 4, negative 6, and has a slope of negative 2. Here's one last problem, probably the most challenging one we've covered to this point. It says write an equation of the line that passes through the pair of points 8, 5, and 4, 6. This is the most challenging problem we've covered because we don't know m or b. We don't know the y-intercept or the slope. So what we need to do is just start finding things, essentially. The first thing we want to find is m. That's our slope. Now remember, we have a slope equation that can help us do that. We have x1 and y1, we have x2 and y2, and if we plug them into the slope equation, then we'll have an m that we can plug in. So let's see, y2 minus y1, x2 minus x1, 6 minus 5 gives me 1, 4 minus 8 gives me negative 4, so my slope is negative 1 over 4. Now let's go back to our equation. Y equals negative 1 over 4 x plus b. Now we still don't have our b. That's the thing we need. Just like the last example, we can actually use some of these coordinates as the x and y. We can plug them in for x and y to solve for b. So let's do that. Now I'm going to use 4, 6. You could get the exact same answer by using 8, 5. It doesn't matter which one you plug in, as long as you make sure you're getting the x and the y in the right location. So I'll plug in a 6 for my y. I have negative 1/4 for my slope. Again, I'm going to use parentheses around my x. That's just to help me remember that I need to multiply. Now, 6 is equal to negative 1/4 times 4, which is negative 1, plus b. And in order to get my y-intercept, I need to isolate that b, so I'll add 1 to both sides. That tells me that b is equal to 7, which is the y-intercept I was missing all along. Now, it's really easy to forget that last step. We've already said this, but make sure you actually write the equation of the line. So I want to go back in and say y is equal to 1/4 x, negative 1/4 x, plus b, or in this case, plus 7. So there you have it. There are a couple different ways you can write the equation of a line, and it really depends on what information you have. You have to start with the slope. You might be given the slope, you might need to use the slope formula, you might need to use what you know about parallel lines, or even look at a graph, but you have to find the slope first. Then, find the y-intercept. Often that means you're going to use the coordinates of a point, plug them in for x and y, and solve for b, the y-intercept. Finally, don't forget to actually write the equation. Now, when you write the equation, I left a little memory here. Don't forget that x and y need to be written as variables. When you write this equation, these cannot have numbers in their place. The final equation has x and y as variables. M and b should be numeric. So that's what we've got for today. Thanks for being here. I really appreciate you watching this video. Make sure you subscribe so you can keep up with all the middle school math content that I'm posting. I appreciate you being here, and I look forward to seeing you next time. Have a good one.